Welcome to the Developer Service YouTube channel. On today's episode, we're going to see how to build an AI chatbot for question and answering on any website. What does that mean? That means that we'll be downloading and reading the content of a website that we'll pass as a parameter. We'll be going to be indexing that website, and then we're going to use AI to ask questions about the content of that website. As always, I will leave a link in the description for the blog post and also how to get the source code. And let's see how we can implement our AI chatbot. Before we begin, let's see an overview of the technology stack that we are going to use to implement this AI chatbot. We're going to be using Python, of course. We're going to be using LangChain and Mistral AI for orchestrating the AI in terms of reading the content of the website and also executing the answer. We're going to be using FAAS, which is a library that allows the indexation of large data sets, and that will be used together with LangChain. And of course, we're going to be using Beautiful Soap and also requests to download the content of the website. In terms of organization of our project, it will be comprised of 4 files. There will be searchlinks.py that will contain the downloading of the content of our website. The createindex.py, which will be indexing the website content using the FAAS library. The chatbot.py, that by using Mistral and LangChain, it's going to be allowing the conversation for answering questions about the content of the website. And of course, finally, the main.py, which will be our main executable file, which will put together all the logic implemented in the other files. So let's start by seeing the requirements. Of course, we have requests, we have LangChain, we have Beautiful Soap, we have Mistral AI inside the LangChain, we have the FAAS CPU, so we can do the indexing, Python decouple to allow us to create environmental variables, and Playwright to help us with, together with Beautiful Soap, to download the content of a particular website, especially if it's using JavaScript. So besides our requirements, since we are going to use Mistral AI in terms of the large language module, you're going to need an API key in order to execute calling that API. So you can sign up if you have not signed up already under Mistral AI. You just click the Build Now button and you sign up. And after you put in your payment information, then you can create an API key. After we have that API key, of course, we're going to put it in our environmental variables with Mistral API key, and you will paste here the API key that you have created under Mistral AI. Okay, let's now see our different files are executed or implemented. First, we start with the searchlinks.py. We have our imports there, mostly related with requests and Beautiful Soap. We also have HTTP basic authentication in case we're scraping a website content that requires authentication. So we have a couple of functions that will help us download and get the content of our website. First, we define a function that gets the links from particular HTML. So we pass in a particular HTML content, and we have defining an inter function, get HTML, which pretty much from a particular element will get the href, and we are returning a list where we are mapping all these links and using Beautiful Soap to extract the content of that website and selecting all the hrefs there. So with the help of the inner function, we can iterate through the different elements, that is return for the Beautiful Soap, selecting the href, we iterate through those elements, and we are creating a list, which is the output of this function. The main function itself, or the function that does the most of the searching, that is implemented in find links, that receives a domain and the URL, also receives a list of the already searched links, and can optionally receive a username and password in case we need to use HTTP basic authentication, as mentioned before. One of the first things that we are doing inside the function is checking if we should be scraping that particular URL that is find or not. So obviously first we are checking if we have already scraped that URL, so if it's not in the search links. We're also going to be excluding the mail tools. We're excluding links that might be a telephone number. We're excluding links that might be a script with JavaScript. Also excluding links to images, because obviously we don't want to script those. And we're also excluding links that might be for authentication pages, which we do not have any interest in scraping that. And also links that might be anchors, we're also excluding that. And finally, of course, we're not, with this particular validation, we're not going for external links. So we'll only be scraping links that belong to that domain. That's why besides the URL that we are scraping, we're also passing the domain, so that we can check that each URL that we are scraping belongs to that particular domain. Then we're checking if we have passed the username and password. And if that is the case, then we're going to create get requests with the URL that we have passed, of course, and in this case using the authentication. If we have not passed the username and password, then we're just going to get the request from that URL. We append that URL that we already searched to the list of search links. Just for debugging, we print the URL that we are scraping. And from that URL, we're going to get all the links by using the previously defined function to get links from HTML that we are passing the contents of the HTML. And for each of these links, we are implementing the recursive function here. For each of the links that we have found, we'll be calling this function again, passing again the domain, but now we're passing a new URL that we have found from searching the URL that we have just downloaded, and of course we're passing the same inputs as we received before. All this logic is orchestrated by the public function, let's call it like that. It is the search links, which receives a domain or a URL, and optionally also username and password. This pretty much just takes care of setting up the list for the search links, of calling the initial call to the find links with the domain and the URL, and returns the output of the list and of the scraping of the URLs to the main.py, in this case, that we'll be using that. So the goal of the search links file is to go through a particular website and scrape all the links that might be of interest to download and return that output. Okay, let's now see, now with the list of links, we can start downloading the content of the website and creating our index. So for that, we're going to define all that logic in the createIndex.py. So we're going to do the imports related with LangChain and also the test splitters, and of course Mistral AI to do embeddings in this case. Later on we'll be using the chat functionality. So first we are going to be implementing a series of functions that help with getting the content and downloading the content and indexing the content of our website. So first we are going to load a particular document from a URL. The load document is LangChain logic, meaning that we are downloading the content. So we are creating an asynchronous Chromium loader. That is so that we can download the content of our website. We are loading that content to this HTML variable, and by using Beautiful Soap and a Beautiful Soap transformer, we're excluding some of the tags from that HTML. That's why the transformation. So we want to extract the body tag, but we want to skip any script, style, headers, and footers because that is not necessary. And that is going to be our documents that are being processed from LangChain, and we'll return those documents for the function that is calling it. The next function is a helper to split these documents. So these documents that we have just downloaded in the previous function, we're going to be splitting them. Splitting them means in terms of the chunking that is done with LangChain to be able to index the contents, meaning splitting the text into different chunks, in this case a chunk size of 1500 tokens, and with an overlap of 150 to make sure that there is no content gaps in terms of the splitting. So defining a recursive character text splitter from LangChain, and we're going to be splitting the documents, and that returns the list of text from the documents that have been split. With that, with those texts, we can index the site. So we're creating an instance of the FIS database, and we're creating that instance from the documents, and that particular document is the text split that we have just had. We're using Mistral AI embeddings, and of course we're passing the Mistral API key that we have defined in the environmental variable. We're saving this file locally to the disk because if we're indexing a website, we only need to index it once, and we can run the chatbot several times to ask questions. So we do not need to be always creating the index. So we just start the index to the disk. and the main public function that is used by the main.file later on. So pretty much just runs this structure. It loads the documents, it splits the documents and gets the list of text, and then indexes those the content of those split text into the files database by saving to the disk. Next, we are going to be implementing our chatbot, which is defining the chatbot.py file. Again, the imports related with the LangChain, and in particular this case we have the LangChain both for the embeddings, because we're going to be retrieving again our embedded content, and also for chatting with the Mistral AI. So first we define a function that will retrieve the index that has been saved to the disk. So again, we're creating an instance of the files database. In this case, we're loading it locally from the folder or the path that we have defined in the save from the previous file. Again, we're passing the embeddings because we need to have an embedding function to be able to create a database. Again, the Mistral AI. We need to allow for deserialization because loading the files database can incur security risks, and so it's not a good practice to load the unknown files into a files database. But in this case, we know the content and we trust those contents, so we're allowing to be possible dangerous deserialization there. And for the LangChain and for the chat, we're creating a retriever from that database with a particular search type, and we want 8 similar possible contents in this case, and with a maximum token limits of 4097. So of course we're retrieving that, we're returning that retriever. Then we have the function that defines how to start this chat. So the start chat function, it uses the retriever that we had just seen from the other function. It creates a memory so that we can have a memory with the chat, and it remembers previous interactions of the conversation. We're doing that with the conversation buffer memory from LangChain. We're defining the memory key, also the input key in terms of the question and the output key of the answer. And of course, we want to return the messages. So then we have the Mistral AI creating the model. So that's it with the chat Mistral AI. We're using the Mistral 87B, so the Mistral mixtures of Mistral AI with the Mistral API key. Okay, again using our config. We're doing a temperature of 0.7, depending on how inventive the chatbot might be with a particular content, we can reduce this temperature. And of course, with our model, we're creating question and answer chain from LangChain, which is a conversational retrieval chain. In this case, we're creating from large language module. So this module, we're passing in the retriever that we have created before. We want to return the source documents, although we're not using it below, but we want to return it as a possibility. And of course, we're passing in the memory. And lastly, we have the public function of this file, which is the chatbot, where it receives a chain and also receives a question. It has some debugging information. It's loading the answers. It's going to invoke the chain with the question, and that will produce the results, so calling the actual large language model. And then it's going to just print out the question. Optionally, we can go through each of the source documents and also print that as part of the reply or the response of the AI. And finally, we have our min.py file. In terms of the imports, of course, we have the imports of all the functions that we have seen from the files that we have defined previously. So we're defining the domain that we want, in this case the developerserver.io website. The URL, it's going to be the https developerserver.io. So we're going to use the search link function that will return us a list of the links present in this URL. We're going to be creating the index from those links by using the create index and the file database. We're going to be starting the chat, and that will return us a chain. With that chain, we're going to be calling our chatbot. So first we're going to be asking question. That question is actually not exit, meaning we don't want to exit the chat. We're going to be calling the chatbot with the chain and the question, and that calls the AI, the Mistral AI, and retrieves the reply. And then we're calling again a question after that reply. So while that while loop is going on, we can be asking questions and receiving the answer. Okay, let's now see our chatbot in action. Of course, if you have not installed already, you're going to need to install the requirements with the pip install -r requirements.txt. I have already installed, and now we can run the file. I'm going to use, in this case, the run from PyCharm to run the file, and we'll see what has happened. So it will first start getting a list of the. So as you can see, we have an error because we are trying to run, and we have not finalized the Playwright installation. So besides, in this case, as we are using the Playwright, besides installing the Playwright as a requirement that we have here, besides installing as part of the requirements .file, we also need to install the components of Playwright so that it can install the different web browsers. So I have run that command. You can see here that I've run the Playwright install, and it has downloaded the different possibilities of web browser, like the Chromium, the FFmpeg, Firefox, and of course the WebKit. So keep in mind that if you have not done Playwright installed before, you might need to do the Playwright installed after you install the requirements, of course, to be able to run this code. So, okay, let's run our code again. So our script will start by trying to get all the links from this particular URL. In this case, it only has this. It has another link, but it's an external link. So we're just capturing this. We have performed the search. We have created the index. We have started the chat, and now it's ready to reply to our question. So we're going to ask a very simple question. We're going to ask, what is this site about? It's loading it, so it's meaning it's performing the vector search on the index database, and it's now retrieving the answer. Let me just write this content, and as you can see, it provides a description of what is this website about. So as you can see, it can provide us with a very detailed answer about the content of this website, and that is the whole goal of having this AI chatbot, so that we can quickly ask questions about the particular website that we have indexed. And we can continue to ask questions, or we can type exit, and then that will finalize the execution of our AI chatbot. That is all in terms of the code that is necessary to run this chatbot. Of course, if you want to go through different websites, you can just change the domain here in the URL. So, like this video if you like this content, and if you like this chatbot, subscribe to the channel to be notified of new content, and to follow me and my new content, mostly about Python and Django, and of course AI, as you've seen here. Thank you for watching, and until next time, happy coding.